Welcome, space weather enthusiasts. A major solar storm is racing toward Earth, and it's shaping up to be a significant event. NOAA's Space Weather Prediction Center has issued a G3 geomagnetic storm alert, meaning strong auroras and possible minor tech impacts. This storm was launched from the sun a couple of days ago, following a powerful solar flare, and is part of a series of recent solar eruptions. We're tracking its progress in real time, using advanced models to predict its arrival and strength. For those in mid-latitudes, this could be your chance to see the northern lights. For satellite operators and power grid managers, it's time to be vigilant. Interestingly, this solar event coincided with a notable earthquake in Alaska, sparking online speculation about a possible connection. While science finds no proven link, the timing has certainly captured the public's imagination. Over the next few days, we'll be watching the skies and our instruments closely as the storm impacts Earth's magnetic field. The strongest effects are expected to last 24 to 48 hours. In this video, we'll break down what a coronal mass ejection is, what a G3 storm means, where you can see the aurora, and explore the intriguing seismic and atmospheric data. Buckle up as we dive into this incredible solar storm and its journey to our planet. To understand what's coming, let's look at the sun, a dynamic, sometimes violent star. Sunspots are regions of intense magnetic activity. When their magnetic fields snap, they release solar flares, bursts of energy that reach Earth in about 8 minutes. This event began with 2 flares, a strong M8.1 class, followed by a smaller M1 class, causing minor radio blackouts. But the real story is the coronal mass ejection, or CME, a massive eruption of solar plasma and magnetic fields. Unlike flares, CMEs travel more slowly, taking 1 to 4 days to reach Earth. When a CME is Earth-directed, it's like a magnetized cloud heading straight for us. Our satellites, like SOHO, captured stunning images of this eruption, a halo CME, which means it's coming our way. These events are tracked closely because they can trigger geomagnetic storms. The CME we're tracking was launched directly from a sunspot facing Earth, setting the stage for the storm. This is space weather in action, and it's why scientists and sky watchers are paying close attention. Let's see what happens when this CME arrives. When a CME hits Earth, its magnetic field interacts with our magnetosphere, causing a geomagnetic storm. NOAA's Geomagnetic Storm Scale, or G-scale, rates storms from G1, minor, to G5, extreme. G1 storms cause weak power grid fluctuations and auroras at high latitudes. G2 storms are moderate, with more pronounced effects. The current forecast is for a G3 storm, strong enough to require voltage corrections in power systems and cause satellite orientation issues. G3 storms can push auroras much further south, sometimes visible in Oregon, Illinois, or Pennsylvania. G4 and G5 storms are rare but can cause widespread power grid problems and satellite damage. While we expect a G3 event, some models suggest it could briefly reach G4 levels, so we're watching closely. For most people, the main impact will be the chance to see the aurora in unusual places. For industries, it's a reminder to stay alert and prepared. The G-scale helps everyone understand the potential risks and excitement of space weather. As the storm approaches, real-time monitoring will be crucial. Let's look at what makes this particular event unique. This solar storm is especially intriguing because it's a double-burst event. 2 CMEs launched in quick succession from the same sunspot. Sometimes, a faster CME overtakes a slower one, merging into a more powerful cannibal CME. Our models show these 2 CMEs merging just before reaching Earth, intensifying the storm. This is why the forecast was upgraded to G3. The merged cloud is expected to arrive late on December 10th, with the main impact through December 11th. This timing is great for North American aurora chasers, as peak intensity should occur overnight. Satellites like DS-COVR and ACE, stationed a million miles from Earth, give us a 30 to 60 minute warning before the storm hits. Their data on speed, density, and magnetic field orientation is crucial for last-minute forecasts. We'll be watching these feeds closely to confirm the storm's strength and timing. Now, let's address the intriguing coincidence with the Alaska earthquake. As the sun unleashed its flares, a magnitude 6.8 earthquake struck offshore Alaska, an uncanny coincidence that sparked online debate. Many wondered if the solar flare could have triggered the quake. Mainstream science says there's no proven connection. The energy from solar storms is minuscule compared to tectonic forces. Earthquakes are driven by plate movements deep within the planet, not by solar activity. Still, humans are natural pattern seekers. and the timing is compelling. Some fringe theories suggest electromagnetic energy could influence seismic activity, but there's no solid evidence. Both events provide valuable data. Seismographs reveal Earth's interior, while satellites track the sun's behavior. Studying them in parallel pushes us to ask new questions, but for now, science calls it a fascinating coincidence. Let's turn to the most beautiful effect of this storm: the aurora. The highlight of this G3 storm is the potential for widespread aurora, the northern lights. Energized solar particles funnel into Earth's atmosphere, colliding with oxygen and nitrogen to create glowing colors, mainly green but sometimes pink, red, or purple. During strong storms, the auroral oval expands, bringing the lights to much lower latitudes. In North America, auroras could be visible as far south as Oregon, Illinois, and Pennsylvania. In Canada and northern states, the display could be overhead. In Europe, the aurora may dip over Scandinavia, the UK, and parts of Germany and Poland. The best viewing is during the storm's peak, overnight December 11th into the early morning of the 12th. To maximize your chances, get away from city lights, find a clear view of the northern horizon, and be patient. The aurora can appear in bursts, so give your eyes time to adjust. Check local weather for clear skies, and try a long exposure photo. Even faint glows can be captured by camera. This is a rare opportunity for many to witness nature's most spectacular light show, but the storm's effects go beyond the sky. This period of heightened activity has also drawn attention to the Schumann resonances, Earth's natural electromagnetic heartbeat, generated by lightning in the cavity between Earth's surface and the ionosphere. These resonances can be influenced by solar flares. Some observers noted unusual Schumann patterns and low-frequency vibrations around the time of the flares and earthquake, fueling speculation. Scientifically, solar flares do affect the ionosphere and can change Schumann resonance intensity. However, connecting these changes to earthquakes lacks solid evidence. Online, some point to geometric coincidences and ley lines, but these ideas fall outside mainstream geology. Still, they highlight our desire to find patterns in nature's chaos. Ultimately, it's a fascinating intersection of science, data, and human curiosity. In the next 72 hours, the main event is the CME's arrival and passage. Forecasts call for strong G3 storm conditions, with a chance of brief G4 periods, meaning minor power grid issues at high latitudes are possible. Satellite operators will monitor for anomalies, while the public can look forward to stunning auroras. Check space weather sites and DSCO-VR data for real-time updates and aurora forecasts. GPS systems might experience brief inaccuracies, but most users won't notice major effects. The sunspot region responsible for this storm is still visible and could produce more activity before rotating out of view. We're entering a dynamic phase of the solar cycle, so more storms are likely in the coming months. This event reminds us of our place in the cosmos, protected by a magnetic shield orbiting an active star. Stay informed, look up, and enjoy the show as the universe puts on a spectacular display. We'll keep you updated as this space weather story unfolds.